The first example that I want to do is this one. Let's say I have the function s of t that's given by root of t times 1 minus t. And the question is, what's the derivative? So the derivative of this function, which we denote by s prime. Can you see from there? Okay. If you can move to the other seat over there. So in order to take the derivative, I can apply the product rule, for example. Notice that this function is the same as t to the half times 1 minus t. And so if I apply the product rule, what do I get? I take the derivative of the first factor, which is what? Half t to the 1 minus a half, half minus a 1, which is negative half. And then you multiply that by the second factor as it is. Plus, you keep the first factor as it is, and then you multiply by the derivative of the second factor. And what's the derivative of the second factor? Derivative of 1 is 0, derivative of negative t is negative 1, right? So you get negative 1. And so what we have then, we have, if we want to simplify this, we have half t to the negative half minus half t to the what? When I multiply with t, I get half, right? And here I have negative t to the half. So at the end, I have half t to the negative half minus 3 half t to the half. I can combine the last two terms. Is everybody okay with that? So that's the derivative of this function. I want to redo this problem again, just to make a point. So I'm redoing the same problem. What is s of t again? S of t, remember, was t to the half 1 minus t. And before I take the derivative, I'm going to multiply out. So I get t to the half minus t to the 3 half, right? If I multiply out. And now if I take the derivative, I get half t to the negative half, right? Half minus a 1. And then minus 3 half t to the 3 half minus a 1, which is what? 1 half. And notice that this time I didn't have to do much simplification. The answer came out much simpler than when I applied the product rule, right? So the point is, sometimes before you take the derivative, if you can easily multiply out and write everything as powers of t or x and apply the power rule, your answer will be much simpler right away than when you apply the product rule. Yeah. This is fine. Yeah. Okay, so any questions on this example? Here's another example. Let's say I have the function y, and that's x squared minus x minus 6 over x cubed plus 6. Okay, so how would we find the derivative of this guy? With this function, I have to apply the quotient rule. Okay, so how would I find the derivative? Anyone wants to sing the formula? No? Okay, so you take the square of the denominator, right? And in the numerator, you take the difference of two terms. What's the first term in the numerator? The first term is you write the denominator as it is, and then you multiply by the derivative of the numerator. What's the derivative of the numerator? Let's put what's that? 2x minus 1 by using the power rule, because the derivative of 6 is 0. And then minus, now you write the numerator as it is, and then you multiply that by the derivative of the denominator, and the derivative of the denominator is 3x squared. So that's what you get. If you need to simplify this, all you have to do is multiply out everything and collect like terms. So if I multiply out everything, what do I get? 2x to the 4 plus 6x minus x cubed minus 6, and then minus what? 3x to the 4, and then it will be a plus 3x cubed, and then I'll get a plus 18x squared, right? The whole thing will be over this. Say it again. I am multiplying through here, but I have a negative here, so I'm actually distributing that as well. So negative x squared times this, negative x times this, negative 6 times this. So that's how I'm getting positive 18x squared. Was that? Where do I have?
X to the 4th plus 12x.
Oh yes, I had a 6x over there. Yes, that's got to be a 12. Thank you. So this would be a 12x. Let me make sure I did it correctly again. 2x to the 4, 12x, negative x cubed, negative 6, negative 3x to the 4, positive 3x to the cubed, and positive 18x squared, yes. And now you collect the like terms. 2x to the 4 minus 3x to the 4, that's negative x to the 4. So this one is gone. Negative x cubed, positive 3x to the 3, so that's 2x cubed. And then 18x squared is as it is. What else? 12x and minus 6. And I have this thing over x cubed plus 6 squared. So that's the simplified answer. Any questions, anyone? Any questions at all? Okay, here is a question. Let's say find the equation of the tangent line to the graph of y is equal to root of x over 1 plus x squared at 1 comma at the point where x is 1. at the point on the graph where x is 1. Okay, so that's the question. Remember, did you guys need a little bit time to write it down? So how do I find the equation of the tangent line? Well, in order to write down the equation of a line, what do I need? I need to know one point on the line, and I need to know the slope. And then if I know a point and the slope, then I can use the point-slope formula to write down the equation. And so the question is, first of all, which point corresponds to x equals to 1 on the graph? When x is 1, I have to figure out what's the second coordinate of the point, right? So yeah, so you just plug in. So if x equals to 1, then the y value is root of 1 over 1 plus 1 squared, which is half. So we are talking about the tangent line at the point 1 comma half. Okay? And what's the slope of the tangent line? The slope of the tangent at x equals to 1 is what? The derivative of the function evaluated at 1, right? The slope of the tangent at the point where x is 1 is given by the derivative of the function at 1. So we have to find the derivative at 1, right? So how do I find the derivative at 1? Well, I first of all find the derivative. What's the derivative? Well, we have to apply the quotient rule. So I take the denominator squared. I have the denominator multiplied by the derivative of the numerator. What's the derivative of root x? What's the derivative of root x? Notice that root x is the same as x to the half. So by the power rule, we know that the derivative would be what? Half x to the half minus 1, which would be negative half. Okay, so minus the numerator multiplied by the derivative of the denominator. The derivative of the denominator here is what? 2x. Is everybody okay with that? Okay, you can simplify this if you wanted to, but I am not interested in that derivative. I am only interested in the derivative evaluated at 1. So without simplifying, I'm just going to plug in 1 and then find out what is y prime of 1. So what is that? This would be 1 plus 1 squared times half times 1 to the negative half minus root of 1 times 2 times 1 over 1 plus 1 squared, that whole thing squared. Okay, what is that? Yes. First of all, you get a 2 from here. That 2 will cancel out the half. And then 1 to the negative half is what? 1. This guy is 1, this guy is 2, so you have 1 minus what? 1 minus 2. So altogether, you are getting minus 1 here. And in the denominator, you get 2 squared, which is 4. Okay? So that's the slope then. So what's the point again? The point was 1.5, right? 1.5, and the slope is negative 1/4. So if I apply the point slope formula, what do I get? The equation of the tangent at x equals to 1 is given by what? Y minus, what's the second coordinate? 1/2. What's the slope? And x minus the first coordinate of the point is 1. So that's it. If you want to write it in the point slope formula, maybe your web assign likes point slope formula. Web assign I think may like the answer in the slope intercept form. So in that case you have to solve for y. So what would be y? Y would be negative 1/4 times x minus 1 plus 1/2, right? And then if you simplify that, you get negative 1/4 x. You get a positive 1/4, right? Plus 1/2. Positive 1/4 plus 1/2. And what is that? So what do I get for y? Y is negative 1/4 x plus 3/4. So that's the equation of the tangent line to the graph of the fraction at the point where x is 1. Is everybody okay? This question, 99% of the time, it appears in any of the exams that I write. Okay. So if that gives you a clue that the same question will be in the exam with a maybe different function. Okay, different value of x, different function, but same question. Okay, everybody is okay with that. Page 127. Where is my page 120? Okay, something happened to my page 128, but that's okay. If I ask you what's the derivative of this function, what did you say? Suppose I have that y is 2 to the 50. What's the derivative? What's the derivative of y? What's that? What's that? It's 0. Okay. The reason this is a sort of a tricky question in the sense that you look at this quantity, even if you look at this quantity, right away your mind concentrates on that exponent, and right away you think about applying the power rule, right? However, notice that it is 2 to the 50 is just a number, it's a constant, so the derivative would be 0. Okay, so be careful with this type of trickier functions. Okay. If you are asked to find the derivative of, let's say, g of x equals to 1 over x to the 5, would you apply the quotient rule? You could. Notice what's going to happen if I apply the quotient rule. If I apply the quotient rule, it's going to be x to the 5 squared, right? And then in the numerator, what do you have? You take the denominator multiplied by the derivative of the numerator, which is 0. A lot of people make a mistake right here, because instead of writing 0, they would write 1. And then minus the numerator multiplied by the derivative of the denominator, which is what? So let's see what I have. I have 5x to the 4 divided by x to the what? 10. And that's all together is what? Let's just write x to the 6 in the denominator like this. Notice that instead of doing that, you could have said g of x is x to the negative 5, and then g prime of x is negative 5x to the what? Negative 5 minus 1, right? Which is negative 6. And you right away, hey, what happened to my negative? There is a negative here, right?
Subtract.
Yeah. So this would be negative 5 over x to the 6. So you get the same answers. But I would prefer the second one, because the first one you have to do a little bit more work, I think. Okay. So again, if you could do a problem by using the power rule instead of using the quotient rule, that's usually what you should be doing if you are looking for a simplified answer. Okay. Here's another example. Let's say I have the function y is equal to 3x squared plus 2 root x over x. Now in this case, again, I can apply the quotient rule, okay? I can apply the quotient rule, but I won't because if you apply the quotient rule, if you need to simplify your answer, you have to do quite a bit of algebra to simplify. But instead, if you realize that you can write it as 3x squared over x plus 2 root x over x, then you would know that this is y equals to 3 times x plus 2 times x to the what? Negative half. So then the derivative is pretty easy. It's 3 plus 2 times the derivative of x to the negative half. Applying the power rule, negative half x to the negative half minus 1, which would be what? Negative half minus 1 would be negative 3 half. Is everybody okay? And then this is just 3 minus 1 times x to the negative 3 half. Is everybody okay with that? Everyone's okay with that? No, if you write 1 over x to the 3 half, that's even better. What's my most favorite? It's probably I left it in the morning class. Okay, I found my page 128. Okay, so any questions so far? So this is it. I don't want to do any more examples in 2-3. You have an assignment waiting for you from 2-3, which would be due on Thursday. One would be due on Wednesday in the WebAssign, which is on section 2.2. So I'm going to stop with 2.3 right now and move on to a different topic. And what I'm going to be speaking about now is the chain rule. And that's the topic from 2.5. I'm not going to skip 2.4, but I'm going to coming back to 2.4 after I am done with chain rule. Okay, so keep in mind that chain rule is in section 2.5. So here's so let me just explain what that is by using some examples. If I give you the function f of x is equal to x squared plus x minus 1 to the 50. If I give you this function, you cannot apply the power rule. Okay, the power rule is just for x to the 50. If I have x to the 50, then I can take the derivative by using the power rule. This I cannot use the power rule. Right? Now, so those of you who know the chain rule already, just forget about it for now. If I ask you to do this problem right now, how would you do it? Yeah, you just multiply x squared plus x minus 1 50 times, right? And then after you multiply 50 times, you write everything in terms of powers of x, right? So that is, if you are an ancient guy and you have no work to do, you don't do any farming or anything, you don't have to feed any family, and so you just have time to be in a cave and just do that, you could. Well, nowadays, of course, you can use a computer algebra system to do it. But the point is, at this point, if you want to do it, the only way you could do it by multiplying out using the power rule. That's the only way of doing that with the formulas that we have learned so far. However, we have this chain rule that's going to save us. We can take the derivative of this very easily. So how does the chain rule work? Well, chain rule, a lot of people are really afraid of chain rule. A lot of students I see at the end of the calculus course, they still can't use chain rule. Chain rule is really what you dream of. Okay, chain rule is what you wish that happens. Okay, so let's see what I mean. You look at this function, right? You look at this function, and you wish your maybe Halloween wish is that this is just x, right? The quantity here, maybe Christmas wish. Yeah. So you wish that this is just x, right? You wish this is just x, because if it were just x, you can just apply the power rule, right? Well, your wish almost comes true. The way you take the derivative, the way you take the derivative is you assume that you have x there. That's what you wished for. That's what you get. You think that's x, okay? And then you take the derivative, thinking that quantity is just x. So, if you apply the power rule, what did you get? You apply the power rule, what did you get? You would get this, right? Yeah, 50. So that's what I was wishing for 5. Okay. So this is you get exactly that if you apply the power rule. But then what you have to do is multiply by the derivative of the quantity that you wished was x. So take the derivative of the quantity that you wished was x, which means you take the derivative of this quantity here. But that's easy. That's just what? 2x plus 1. And that's exactly what chain rule is. I'm going to talk about that later in general, but that's how it works. Let's look at another example. Let's say I have the following function y, which is root of 1 plus x squared. It's the root of 1 plus x squared. Notice that this quantity is 1 plus x squared to the half. So once again, you look at this function, you wish that 1 plus x squared is just x, right? And so take the derivative, assuming you have just x to the half, and the derivative would be half times that to the half minus 1. And then you multiply by the derivative of the quantity that you wished was x, and that the derivative of that is what? 2x in this case, and that's the derivative. One thing that I want to point out here is that in the first case, notice that we have a composition of two functions here. The function in the first example, notice that that function is the composition of x to the 50 and x squared plus x minus 1. So if you take the composition of these two functions, so x to the 50 is the outside of the function, x squared plus x minus 1 is the inside of the composition. If you take the composition of these two, you get exactly f. Okay? And what we did is basically we took the derivative of the outside, evaluated at the inside, multiplied by the derivative of the inside. That's what we did. In the second example, the outside is x to the half, and the inside is 1 plus x squared. So you take the derivative of the outside, evaluate at the inside, multiplied by the derivative of the inside. Same thing happened in the second example. Is everybody okay with the two examples? Let's look at some more. Let's make it a little bit more difficult. Let's take the function g of x to be root of 5 plus 1 plus x squared, root of that. So let's say that's the function that I have. So how would you take the derivative now? Well, first of all, let's write them out in terms of powers. So this would be 5 plus 1 plus x squared to the half, and then I have exponent half altogether, right? That's what it means. So how would I take the derivative? Once again, you look at this, you wish you had just x to the half like this. So you take the derivative, assuming that that quantity is x, so you take the derivative, your wish comes true, you think that's just x, so this would be half times x to the half minus 1. So that x for you is this. And then what? Well, you have to multiply by the derivative of the quantity that you wished was x. So that's this quantity. You take the derivative of the quantity that you wished was x. Okay. But this would be half 5 plus 1 plus x squared to the half. This would be negative half. And derivative of 5 is 0. Now again, you have to take the derivative of this quantity, right? Well, again, you look at this quantity again, and your second wish, my son gets to have two wishes for Christmas because he was born on the 25th of December. So he has a birthday gift and a Christmas gift. So here's the derivative of 1 plus x squared to the half. What is that? Well, you wish that this was just x, so you take x to the half. So what's the derivative? The derivative would be half 1 plus x squared to the negative half, and then you take the derivative of the quantity that you wished was x. In this case, that's 1 plus x squared. If you take the derivative of that, you get 2x. So the point of this example is I applied the chain rule twice. Whatever the chain rule is, I'm going to explain that later. So basically, in the function that we started with, this function that I have here, it's the composition of three functions, okay? And so first of all, you have this function x to the half, and then you have 5 plus x to the half, and then you have the function 1 plus x squared. So what you did is you took the composition of three functions. The innermost function is 1 plus x squared. You plug the innermost in this middle one, you get this quantity here, and then you plug that in the outermost, you get the entire function. So the point is here you had a composition of three functions, and therefore you applied the chain rule 3 times. Is that making sense? Everybody's cool with that? Okay. You can apply it 3 times, 4 times, 5 times, 6 times, as many times as is required by whatever complicated function you have. But I wouldn't give you I wouldn't give you a function where you have to apply the chain rule more than 3 times. Okay, at most 3 times is what you have to apply in the exam. Here's an example where you combine chain rule with quotient rule. So let's say I have the function f of x, and it is x minus 1 over x plus 1, and you take the cube root of that. So that's the function you have. And I think this is probably one of the problems that I gave on the exam last time. This is x minus 1 over x plus 1, and what's the exponent? 1/3. Okay, so what's the derivative? What's the derivative? The derivative is given by, you wish that fraction was at just x, so you take 1/3 that fraction to the 1/3 minus 1. Assuming that fraction was just x, this would be the derivative, and then you multiply by the derivative of the quantity that you wished was x. So you take the derivative of the quantity you wished was x, and in that case you have to apply the quotient rule. So I get this, and this would be what? This would be and then you take x plus 1 times the derivative of the numerator minus x minus 1 times the derivative of the denominator, right? And you can simplify that out. Is everybody okay with that? Any questions on that?
Exam, how far did you simplify that?
If the only question that I ask you is find the derivative, this is fine. But again, when you do your homework now, you should practice simplifying your answers, match your answers from the back of the book, because later on in the course you need to be able to simplify the derivatives in many other questions. So you should have the practice now. For one thing, a lot of the times students think that they have the right, they take the derivative, they think they have the right answer, they don't check it from they don't check their answers with the answers from the back of the book, because you have to simplify it and they don't want to do the work. But then you might not know that maybe you have made mistakes in taking the derivative, and if you don't match with the answers in the back of the book, you don't know whether you made a mistake or not. So that's why I assign the odd problem, so that you can check your answers. So here's negative 2/3, and then when you simplify it out here, what do you get? I guess 2 over x plus 1 squared, right? Of course, I mean, if you want, you can also do what? Yeah, this would be 2/3 x minus 1 to the, sorry, x plus 1 to the 2/3 x minus 1 to the 2/3, right? Times 1 over x plus 1 squared. The reason I switched the fraction, the numerator and the denominator, is because I'm making the exponent positive. And now I can combine this one as 2/3, and here I get x minus 1 to the 2/3 and x plus 1 to the what? 2 minus 2/3, what is that? 1/3. Is everybody okay with that? Any questions on that example? So let me finish by saying what does the chain rule say. So what's the chain rule? So what it says is that if you take the derivative with respect to x of f of g of x, and what you end up with is the derivative of the outside function evaluated at the inside multiplied by the derivative of the inside. So if you think about it, for example, in the case of the function 1 plus x squared root of that, right? When we took the derivative of that, this function is the composition of the function root x and the function 1 plus x squared. So how do you find the derivative of this? You take the derivative of the outside, right? And then you evaluate that at the inside and multiply by the derivative of the inside. Is that making sense? So you can so here's so when you take the derivative of this guy outside, you get what? You get half x to the negative half, right? But you have to evaluate that at the inside. So you have to replace x by 1 plus x squared, and then you multiply by the derivative of the inside, which is 2x. Is that making sense? Everybody is okay with that? Okay, so I will be doing more work with chain rule on Wednesday, and Wednesday we'll also get into section 2.4.